here are some sample problems writing ionic compounds. So hopefully I had a chance just to kind of peruse this example with magnesium hydroxide and some iron chlorate. So first thing I got to do is get the charges, right? That's always step one. Get the symbols and their charges. I can find magnesium on the periodic table. It is always a +2. And then if you notice, like, technically we've been saying that the polyatomics usually end in ate or ite. Well, here's a goofball. Hydroxide. Hydroxide really does end in IDE. I got that polyatomic chart over here. Almost all of them end in ate or ite. I mean, there's the cyanide, and there's hydroxide, and maybe the only positive polyatomic is ammonium down at the bottom, NH4+1. That's a goofy one where people will always come up like during a test and they'll say like, I can't find ammonium on my periodic table. Yeah, it's a goofy polyatomic. It's the only positive, NH4+. Now, with cyanide, hydroxide, and ammonium, they're just goofballs that you look up on the chart. Or if you're like looking at your periodic table and you're like, gosh, I can't find anything called hydroxide. Well, then look it up on the chart. Hydroxide is super duper common. And so I guarantee, give it a week and you'll be familiar with hydroxide. So I've got my charges, +2 on the magnesium, -1 on the hydroxide. You can be a crisscrosser or a balancer. Either way, you should end up with MgOH2. And here we did need the parentheses because we have to show that there's 2 groups of hydroxide. When I'm double checking to make sure that my final formula is neutral, MgOH2, then I'm saying, okay, well, magnesium's charge is +2. Each hydroxide is -1, but I have 2 groups of hydroxide. So that's going to give me a total charge of -2 on the back end. That balances with my +2 on the front, and the compound is neutral. Cool, right? And so the 2 skills that we have to master are writing the formula when given the name, or like B, given the formula, can I write the name? And so these compounds, these ionic compounds, will always have 2 parts. There's 2 words. There's 2 ions. There's the positive and the negative. So if you see something like this FeClO3, if you see that formula and you're like, oh my gosh, it's crazy. There's 3 elements. I will guarantee you that there's a polyatomic ion. If you see something in parentheses, I guarantee it's a polyatomic ion. These things only have 2 parts to them. So this for sure is iron. And then look up that part that's in parentheses. Look up that part at the end that might have maybe 2 or maybe 3 nonmetals. Because there's only supposed to be 1 positive ion, that's the metal, and 1 negative ion, that's the nonmetals. So you look it up, and that's where you'll find chlorate. Iron chlorate. And from there, before I say I'm done, remember we just have to check that metal to see if it needs a Roman numeral. Is it a transition metal, tin or lead? In this case, yes. The iron is a transition metal. And so then I know I'm going to need the Roman numeral. Okay, so now to find the Roman numeral, we just kind of backtrack a little bit. And we say, okay, let's look at the charges. This was FeClO3. Well, that chlorate, ClO3, I can look that up on my chart. Chlorate, chlorate. Here it is in the middle. ClO3 minus. which means -1. Okay, so this whole group is -1. And we get that charge not by like adding the individual charges on chlorine and 3 oxygen. Somebody asked that, and it was a really, really great question. The charge comes from putting chlorine and 3 oxygen together. If I want to bond chlorine and 3 oxygen and give them all an octet, I'm going to need 1 more electron. That's where the charge comes from. So it's not like adding chlorine and 3 oxygen, because they were like, well, then wouldn't the charge be like, whoa, minus like 7? Yeah, it's how do I give all those atoms a full octet? And we'll look at these polyatomics a little bit more in the second half of the unit too. For now, I just need to know the charge, -1. Now there are 3 of them. That's what the little subscript tells me, that there are 3 groups of chlorate. So then overall on the back end, I have a charge of -3. Well, there's only 1 iron, so to make it neutral, the iron must be +3, right? Must be +3. Oh, cool. So yeah, then I can just put the charge in 3. So you just balance it. Just find the amount of negative charge and then balance that with the amount of positive charge. Iron 3 chlorate. All right, so let's see if you got these right. 28 and 29. What is the formula for copper 2 nitrate? Oh, I love this one. We use a lot of copper 2 nitrate. It's like the most beautiful blue color. It's like Smurf juice. Copper 2 nitrate. So the copper is charged +2. That's all the Roman numeral means. It just means that the charge on copper is 2 because it's a transition metal. Then when I see the ATE ending, ATE, I'm going to my polyatomic chart. All right, let's find nitrate. Nitrate, nitrate. Oh, there it is. ATE, NO3-. Okay, so I got my formula, NO3, and you could say minus or -1 or 1-. And now we have to make them neutral. So if you are a balancer, you might say, well, easy, +2. Let's just take 2 of these nitrates. 2 times -1 is -2. And if I add that to my +2, it's neutral. We're balanced. If I had to multiply the charge of nitrate times 2, then it means I need 2 nitrate ions in my formula. And so I can put this in parentheses because it's a group, and I'm going to put the 2 on the outside. Now, you could also write this as like copper, nitrate, nitrate. That's what it means. By putting the parentheses around nitrate and the 2 on the outside, it means that we have 2 groups of nitrate. And if the copper is +2 and each nitrate is -1, we've got ourselves a neutral formula. But eventually these things could get a bit long and cumbersome, and so that's why we shorten it with the parentheses. We put the 2 on the outside. Now you would get the same formula if you're a crisscrosser. If you're a crisscrosser, then you would just be crisscrossing the 2 and the 1, not the plus or minus. You don't have to bring the 1 down behind copper. You can, but then you still have to put nitrate in parentheses to show that there's 2 groups. Otherwise it looks like NO32, and in reality there's not 32 oxygen. How many are there? Look at this. There's really going to be 3 and 3. There's actually only 6 oxygen. Oh, there's only 6 oxygen, not 32. That's crazy. So there's my copper nitrate. Gosh, I kind of have that really messy. It would be like CuNO3, 2. That's better. All right, so there's skill number 1. Skill number 2, can I write the name if given the formula? All right, look at this goofy thing. NH4 in parentheses, 2, and then S. Okay, so there's only 2 parts to any ionic compound. There's the positive and the negative. So if you've got 3 elements, I guarantee you have a polyatomic somewhere. And if you see anything in parentheses, that's another dead giveaway. You've got a polyatomic. So when I see that NH4 in parentheses, that sets off like red flags. Ooh, it's kind of weird. I wonder if that's a polyatomic. And so then we go way back to our chart on page 98. And I see, oh, sure enough, here it is, NH4. NH4 is ammonium. Now, unfortunately, it's like a name that doesn't sound anything like nitrogen or hydrogen, right? It's ammonium. All right, so NH4 is ammonium. And I don't have to worry about it being a transition metal or anything that would need a Roman numeral. That ammonium ion, this guy is +1 for life. Then on the back side, I see S. Just regular S is sulfur. And when I have just the regular element, but it's a negative ion, the ending turns to IDE. This is ammonium sulfide. It smells terrible. Ammonium sulfide, super stinky compound. It's like a white crystal. But you open up the bottle and whoa, knocks you over. And the formula makes sense too, because sulfur on the periodic table should always be a -2. And so yeah, if I were going to either crisscross the charges or if I were going to balance, I'm going to need 2 groups of ammonium. Now the one thing that we should just mention is that there can be lots of different forms of sulfur ions. So the IDE, sulfide, the IDE is always the regular element on the periodic table. So this is just S, sulfur -2, or 2-. The IDE is the singular element. Now the other options are the 8s and ites. Sulfate is SO4 -2, and sulfite is SO3 -2. Well, when you see the 8s and ites, those are on the chart. The chart on page 98. The 8s and ites, look them up. You don't have to memorize them. Look them up. But the IDE will just be the regular element on the periodic table.